which is about giant structures. The learning outcome is describe the giant covalent structures of graphite, diamond, and silicon 4 oxide SiO2. First of all, recall the concept of giant structures. Some examples include giant metallic lattice. Examples: giant metallic lattice, giant ionic crystal lattice, and macromolecules. These structures are so big that if you will start drawing the structures of giant structures in a normal flat or house room, you might end up completing each and every corner of the room, but the structure will not end. So let me talk about the definition of giant covalent structure. Macromolecules having strong or many covalent bonds. Macromolecules having strong or many covalent bonds. Which means it is hard to break bonds. It is hard to break bonds or need a lot of energy. Need a lot of energy to break bonds. These are some examples of elements or compounds having giant covalent structures. On left hand side is diamond. This is diamond. And on right hand side, there is a pencil. Pencil contains graphite. In the middle, there is a sand. Sand is also known as silicon 4 oxide. Silicon 4 oxide. Now let's talk about allotropes and allotropy. Allotropes of carbon are example of giant covalent structures. Allotropes are basically different forms of the same element. Allotropes are different forms of the same element. The phenomena is known as allotropy. Phenomena is known as allotropy. Allotropes have different arrangement of atoms in them. Allotropes have different arrangement of atoms. And due to this reason, allotropes differ in their physical properties. Allotropes differ in physical properties like melting point, boiling point, density, melting, boiling point, etc. But they have same chemical properties. Allotropes have same chemical properties because they are or they belongs to same element. Allotropes of carbon. Some allotropes of carbon include diamond, graphite, Buckminster fluorine, Buckminster fluorine, and carbon nanotubes and nanotubes. These are some examples of elements or compounds having giant covalent structure. I have already told you their names. That is from left hand side, diamond. So diamond. This is sand or silicon 4 oxide. Silicon 4 oxide. This one is pencil, which contain graphite. Giant covalent structure of graphite. Graphite has a layered structure. Each carbon atom uses 3 of its electrons to form simple bonds to its 3 close neighbors. The 4th electron in each carbon atom is free or mobile. So we can write each carbon is covalently attached with 3 other carbon atoms in a hexagonal ring in a giant crystal lattice. Each carbon is covalently attached to 3 other carbon atoms, 3 other carbon atoms in a hexagonal ring. In a giant crystal lattice. In a giant crystal lattice. I'm drawing the structure of graphite so that you will have better idea about its structure. You see, each carbon is bonded to 3 carbon atoms and they form a hexagonal ring. Will be like this. The small part of the giant covalent structure of graphite. Now let's talk about diamond. In diamond, each carbon shares electrons with 4 other carbon atoms, forming 4 single covalent bonds. So we can write each carbon is covalently attached with 4 other carbon atoms. Each carbon atom is covalently attached with 4 other carbon atoms. 4 other carbon atoms in a tetrahedral arrangement. Tetrahedral arrangement. In a giant crystal lattice. I will draw the structure of diamond so that you have better understanding and insight about the structure. See, each carbon is attached to 4 other carbon atoms. Giant covalent structure of silicon 4 oxide has the same structure as diamond. Each silicon atom form bond with its neighbors by an oxygen atom. Each silicon atom form bond with its neighbors by an oxygen atom. The structure of silicon dioxide will be like this. We know the structure of diamond. You can draw in this way. The only difference is that we will introduce an oxygen atom between two silicon. Like here you have oxygen, here you are having oxygen, here, and so on. Let's summarize. The learning outcomes for this lesson would be relate the structures and bonding of graphite and diamond to their uses, limited to graphite as a lubricant and as an electrode, diamond in cutting tools. So in this lesson, I will talk about some properties of both graphite and diamond with respect to their structures and bonding. Some characteristic properties of graphite. Graphite has a high melting point. Graphite has a soft and slippery touch. Graphite conducts electricity. Graphite is insoluble in water and organic solvents. Graphite as a lubricant and as an electrode. In order to understand this, I will draw the structure of graphite, which is like this. You see the hexagonal structure? And it's in the form of layer. This is a small part of the structure. You see here, these are carbon atoms. Let me write carbon atoms. And each carbon is bonded to 3 other carbon atoms in this way. Graphite has hexagonal or layered structure, and there are weak forces between each layers. These are weak forces. Graphite has a hexagonal structure or layered structure, and there are weak forces. There are weak forces between each layers. Graphite as a lubricant. Graphite is slippery, soft, used as lubricant. Graphite is slippery, soft, used as lubricant. Now, reasons. You have to give reason for this. It is due to layers, atoms, less closely packed. It is due to layers. You can even write atoms. Less closely packed. Weak forces between layers. Weak forces between layers. No need to write the name of the force, which is van der Waal. You can write layers can slide. Can slide or slip. Don't write atoms slide over each other. Atoms slide over each other. This is wrong. Graphite as an electrode, which means graphite conducts electricity or acts as conductor. Graphite conducts electricity. Now write the reason. Delocalized electrons are free to move. Delocalized electrons are free to move throughout the sheets. or electrons can move. You can even write or electrons can move. You can even write has delocalized electrons. Has delocalized electrons. Now let's see some characteristic properties of diamond. Diamond has a very high melting point. Diamond is very hard. Diamond does not conduct electricity. Diamond is insoluble in water and organic solvents. First of all, I will draw the structure of diamond to have better understanding and insight. This is a small part of diamond. These are the carbon atoms. These are carbon atoms. And each carbon is bonded to 4 carbon atoms to give hard and compact structure. This also does not leave any electron free at all, as all the valence electrons are involved in bonding with other carbon atoms. Electrons are not free or mobile. Diamond in cutting tools. Diamond is very hard and has high melting point, almost 4000 degrees centigrade. Diamond is very hard and has high melting point and has high melting point, like 4000 degree centigrade. The reason it is due to the presence of many covalent bonds. It is due to the presence of many covalent bonds throughout the structure. You can write giant structure. Hard to break bonds. Hard to break bonds. I need a lot of energy. To break bonds. This is the learning outcome of this lesson. Describe the similarity in properties between diamond and silicon 4 oxide related to their structure. First, I will draw the structure of silicon 4 oxide. Recall the structure of diamond. Now what you have to do, just simply place oxygen atom between two sulfur. So this is oxygen atom. The black dots are sulfur atom, silicon atom. Notice that each silicon atom is bridged to its neighbors by an oxygen atom. Don't forget, this is just a tiny part of a giant structure extending on all three dimensions. This one, small part of a big structure. If you look at the structure of silicon oxide, then you will see that it resembles diamond, which means it's also tetrahedral. This also suggests similarities between diamond and silicon oxide in terms of some properties, which I'm going to write in the next slide. So first of all, I will write structure of silicon oxide resembles diamond. That is, it's also tetrahedral. Properties of silicon oxide. It has a high melting point, just like diamond. It has high melting point. The reason, it contains many or strong covalent bonds, because it contains many or strong covalent bonds. It needs a lot of energy to break the bonds. Lot of energy to break the bond. It has hard structure. The reason is same as the one I have explained for high melting point. It has hard structure. It does not conduct electricity. It does not conduct electricity. Again, it is just like diamond, so we can write that mobile or free electrons are absent, because mobile or free electrons are absent.